Hello and welcome back. The topic for this video is going to be balancing chemical equations. And I know you're sitting there going, this is a biology class, why the heck do I need to know how to balance chemical equations? All right, and I'm going to tell you why. All right, the reason why is written up here is because when we're talking about chemical reactions, you aren't actually creating matter with a chemical reaction, you're only transforming what's there. And why that's important is because we as human beings, as a biological organism, we are a walking, talking chemical reaction. We've got chemical reactions going on within our body all day, every day, constantly, okay? So in terms of chemical reactions, it's a little like cooking. You have your ingredients, you need a certain amount of ingredients to get your product out at the end. All right, and in terms of that, baking is also an example of something that involves some chemistry. All right, it's a bit more fun chemistry, but that's okay. The first chemical reaction I have up here, this is actually, you're going to see this again. This is cellular respiration. All right, C6H12O6. This is the chemical formula for sugar, for glucose, oxygen. We've got carbon dioxide, and we've got water, okay? If you notice, I've got an arrow here. The arrow separates the two sides of our chemical reactions, okay? These on the left side are going to be your reactants. And on the, left side is going to be products. Okay? And what separates the reactants from the products is the arrow. All right? Essentially with balancing chemical equations, what you want the same number of each of our elements on this side of the arrow as what you have on this side of the arrow. Okay? So the way I like to approach balancing chemical equations is I use tables, okay? This is going to be our reactants. This is going to be our products, okay? And you just count, all right? The C stands for carbon, 6. This tells you you've got 6 carbons on this side, all right? H is hydrogen. We've got 12 hydrogen on this side. We've got 6 oxygen here, 2 oxygen here. It's separated by a plus sign. You add these together. 6 plus 2 is going to give us 8. Okay? On our product side, we've got just 1 lone carbon over here. We've got 2 plus 1, we've got 3 oxygen. All right, and we've got 2 hydrogen. So that's what I do. I set up the table first because now you can see 6 doesn't equal 1, 8 doesn't equal 3, 12 doesn't equal 2. All right, we want to have the same number on each side. So what we're going to do, typically I try and take and look at, well, what's easy there? All right, there's no easy way that I'm seeing to make 3 become 8, okay? But there's an easy way for me to have 1 become 6, okay? And what we do is we put a number 6 in front of our carbon. And what that's going to do now, when you have a number in front of a compound, you multiply. 6 times 1, and if you need to put in a placeholder there to know that that's 1, that's fine. 6 times 1 is going to give us 6, okay? So now we've got 6 carbons on each side. So we've balanced it for carbon. But that 6 not only applies to the carbon, it also applies to the oxygen. So you have to multiply 6 times 2. 6 times 2 is going to be 12. Plus 1. Now we're going to have 13. It's like, oh dear. I just made oxygen look a lot more ugly. But that's okay, because we're not done yet, all right? We've still got hydrogen. And hydrogen is another one that looks like I can fix that one fairly easily, because 6 times 2 is 12, okay? So I've got 12 over here. In order to get 12 hydrogen on this side, I can put a 6 in front of the hydrogen. 6 times 2, that now makes that 12, okay? So we're good for hydrogen, we're good for carbon. But again, because we put the 6 here, we have to apply that to the oxygen as well, all right? So we have 6 times 2, so we've got 12 oxygen over here. 6 times 1, we've got 6 oxygen over here, that's a 6, okay? So now 12 plus 6, that's going to give us 18 oxygen, okay? So in terms of that, just looking at the table, 18 and 8 don't look very easy. But if we look at this side of our equation, if we go back to the reactant side, there's something we can do over here. So when you balance chemical equations, you may need to add numbers to the compounds that are part of the products, but you may also need to add something in front of the reactants as well. And that's the case with this chemical reaction, okay? So in terms of that, we've got 6 here, okay? So in terms of that, we want to somehow now have this oxygen be able to be made into 12. And the way we can do that, we've got another 6, all right? 6 times 2, that's going to give us 12 oxygen here, 6 oxygen here. We've now fixed our oxygen. We've balanced our equation. So we have the same number of compounds on the reactant side that we do on a product side. That's really all balancing chemical equations is, and that's all you're looking for, all right? I've got another one here. This one will go a little quicker, okay? Again, if we count things up, I always like to start with carbon. We've got 1 carbon on the reactants, 1 carbon on the product side. That's actually looking pretty good. If we don't have to mess with carbon, we don't have to, okay? If we look at oxygen, we've got 2 oxygen. On the reactant side, we've got 3 oxygen on the product side. So we're going to have to do something. But before we do anything, let's look at hydrogen. We've got 4 hydrogen on the reactant side, 2 hydrogen on the product side, all right? So in terms of that, that's the easy one to start with, okay? Because what we can do, we can put the 2 in front of the water. So 2 times 2, that now gives us 4, all right? So we've balanced hydrogen. But again, we have to apply that 2 to the oxygen. So 2 times 1 is going to give us 2. So we've got 2 oxygen here, we've got 2 oxygen here. Now we've got 4 oxygen. But if we look at our table, that one's another one that's an easy fix, right? Okay? So we've got 2 oxygen on this side. If we put a 2 over here, 2 times 2 equals 4. We've balanced oxygen. We didn't put anything in front of our carbons, so our carbons stayed balanced. We've balanced the equation, okay? And really the point I want to make with that is you aren't creating or destroying matter with the chemical reactions that we're going to talk about within the cell. You're transforming them, okay? So those chemical reactions have to be balanced. Hopefully that makes sense. If you have any questions, please let me know.